Day in, day out, it's the same road we're walking down. Same job, same town, 'cause we've been told that's the way our world goes round. Walking on the grounds we've always known, stepping on the footprints in the snow. But when it melts, the other ways will show. We're gonna make the footsteps.
Good evening. My name is Chiazor Michael. I graduated from OKAN20f, studying building technology back in Nigeria. I'm currently in Turkey now, undergoing my master's program in Istanbul University. In this semester, I was interested in a project, Geothermal Energy Design System for Sustainability. I took a particular interest in this project because I believe that most architects, urban planners, and environmentalists have actually neglected this design system, basically emphasizing on the negative effect rather than the positive effect it poses on the built environment for futuristic purposes. A peculiar fact today is that the urbanization of population growth and improved technology caused environmental and energy resource related problems. By using a significant part of the natural resources, construction sector obscures the ecological balance and threatens the environmental health conditions for humans, which affects the human nature environmental relationship negatively. Features of sustainable and eco-friendly urban designs actually have basic features of access to public resources. We have urban renewal actions and renovations. We have reduction of CO2 emissions and reduce, reuse, and recycling. Basically, the net zero energy project used in major cities today. Basically, there are different renewable energy systems used in the world today, and the basics are solar energy, wind energy, hydro energy, basically using the northern European countries or northern part of the world. We have tidal energy, we have geothermal energy, which is, like I said, neglected for so many reasons, basically the negative reasons rather than the positive reason it may pose. So geothermal energy is actually an alternative source of energy that can be generated from the subsurface of the earth. In some cases, it is derived from decomposed landfills, and the heat generated from the decomposed matter is channeled to the surface through water via steams, or with the right duration of decomposition, they are converted into methane gas and can be used for power generation. In some instances, that may be possible, but in some other instances, just energy from the earth. That's why it's called geothermal heat, or heat from the earth, or earth heat energy. Let's put it like that. Is geothermal energy sustainable? Fine, yeah. Geothermal resources is customarily exploited by withdrawing the fluid and extracting its heat content. There are many important examples of how this is accomplished in a total renewable way. Thermal spring in many parts of the world, such as Reykjavik, Idaho, Mazda, Nevada, Perth in Australia, Ontario, Vancouver, and Boston, have actually produced impressive amounts of heat on the surface for centuries without showing signs of decline. As geothermal energy generated, the power plants basically use steam to produce electricity. The steam comes from the reservoir of hot water found a few miles below the earth, usually 12 to 15 meters, and the steam rotates a turbine that activates a generator which produces electricity. And this energy actually rarely depletes, as long as the earth exists. The energy is actually sustainable. So in relation to the environment, how does this really affect the environment? Any type of energy production have some impact on the environment, but the degree or extent of the impact will depend on the technology used. Both of most or both of the main geothermal application of power generation and direct use can have effect on the environment. These need to be identified, quantified if necessary, and eliminated or abated in a way that least order or complies with environmental regulations. In terms of power generation, whatever technology applied has to do with exploration, production, tests, and construction and operations. Those are phases of development in terms of producing power, in terms of generating power. In this case, the environment might have temporary effect due to this activity. It can cause change in landscape or land use, also in emissions into the atmosphere, usually hydrogen sulfide and mercury. Noise control is also an issue with this system, and of course we have seismicity and solid waste. Of course, direct usage is actually the most common, as Iceland has been very successful in this process. This actually, the drill wells are actually 5 to 10 meters apart from the building or beside the building. This case, direct usage doesn't really have impact in terms of noise or have a detrimental effect as the power generation effects are exposed. Seismicity often happen in power generation, and most likely in concentrated areas where drill wells are closely packed together. This can cause natural edge changes and movements, and this is usually common in the artificial methods, which is usually the all dry rock method technology, which was a prevalent method used in Australia. So in conclusion, I was able to compare various of examples in terms of Boise, Idaho. We have Reno, Nevada. We have Perth, Australia. We have some in Australia, Perth, Australia. We have Vancouver. We have Izmir in Turkey. And also we have Sumatra in Asia, or Indonesia rather. So after careful consideration of this matrix of this example, I compare them to various of examples such as cost, technology, population, waste management, water management, water pollution, economic importance, noise, land use, air pollution, health and safety factors, and I was able to draw up some SWOT analysis that could able to draw some basic conclusion that I could be able to use as guidelines or roadmaps to creating my own personal design. And this 4 conclusion, one of it is cost efficiency. Yeah, this is a very, very important case in terms of expense. It's very expensive at the beginning, but in terms of a long-term plan procedure, it's actually the most affordable in a renewable energy system. We have an environmental utopia. In terms of environmental, it has to satisfy some specific environmental conditions instead of creating a kind of symphony with climatic conditions, environmental conditions, and human conditions. We have seismicity, which I mentioned before, as if it's actually one of the reasons why most people neglect this technology or negate this system in urban design. And socio-economic effects or socio-economic relevance, it has to have some sense of relevance, some sense of importance in terms of societal and economic importance in developing the region or the urbanity. So these are the matrix like I mentioned before. I'll go to my design. After careful consideration of the matrix, I was able to come up with a location. This location is actually in Leso Island. Administration is in Denmark. Basically, it's activity is controlled by the Danish government. In this case, this island is actually a perfect place to create a self-sustainable community using this system, as they are used to support from one another. But with this system, I think you can believe they can become a bit independent in terms of power generation, in terms of socio-economic importance, in terms of awareness to technology, and of course changing in ideas in urban design or in the built environment. So in terms of landmark, topographic image, they are all here, and of course Arctic wind, tropical wind, and polar continental wind, as well as climatic weather analysis. This is just basic master plan of how I intend to create the kind of urban utopia whereby the power generation facility will be isolated from urban life, even though the distribution process is actually integrated with the urban activities. In terms of integration of direct usage, that will actually be a very unique way, because creating of urban elements such as square parks and utility tunnels around the city helps in terms of distribution process, and in terms of equipping the city with climatic weather urban elements such as snow melting, heating grids around the city, as well as heating grids around these pedestrian parks, recreational facility, and squares. So the basic design is around, and in this case I took evaluation of the 4 major factors negating cost, of course, because cost is actually in the list of factors I will rather relate this design to, as it is affordable on the long run. Seismicity is a major factor, so I was able to pinpoint locations where I can input drill wells, and those locations can be created as a public area, a square park. Of course, the square won't be as large as most squares in major cities would be, like, as this is a business district and all buildings are closely packed with each other. But with the introduction of these squares, parks, and open areas, it gives license to organizing drill wells and channeling these drill wells together with utility tunnels around the city. Of course, the connection is an hybrid connection, and the urban design planning system is actually a pre-industrial planning system where the historical elements of the cities are maintained while addressing the new system and integrating the new system with the old system. In terms of integration, like, these are the tunnels. In the bottom right of the A3, you see the tunnel, and you see the pipe underneath the city, and of course the green canopies that are creating boundaries around the city to reduce noise as well as increasing oxygen. So this is the master plan of the city, and basically shows the greenery around the city, the boundaries, as each of the sites in the business district are actually open-ended for easy access and for maintenance purposes. The squares that might be located or that are located around the borders or the fringes of the city are actually equipped with heating grids. So during harsh climatic condition, maybe winter period, those in the parks won't actually have the negative effects of the weather condition at that time, and of course the green boundaries, isolating the geothermal power plant housing facility from the urban area. I believe this system is actually a very good system, but as most planners will disagree that it creates or it has not much societal relevance or economic relevance to city or urban development. But I believe that someday in future, this design system will actually be as attractive to others as it is attractive to me. Thank you very much.
Day in, day out, it's the same road we're walking down. Same job, same town, 'cause we've been told that's the way our world goes round. Walking on the grounds we've always known, stepping on the footprints in the snow. But when it melts, the other ways will show. We're